learn how to name molecules. Woo!
So we are going to start with talking about how to name just a simple alkane. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. And here is a little list to help you out with the prefixes of carbon chains. So since we counted 9 carbons, we'll have a non, and since it's an alkane, we're just going to have an ane at the end. So this right here is a non-ane. But what if we were given a molecule that looked like, well, a chain that looks like this? You might think that's kind of scary, but it's not. So again, this has 9 carbons, so we know that it will end in the name non-ane. But you might ask, well, how do I name these guys? These weird things coming out of it. So what you would do is I'm going to start numbering this from this end. So 1, 2, 3, 4, and the first thing you're going to do, let me preface this, is find the longest chain possible. So for me, on this alkane, we have, this is our parent chain because it's the longest. We wouldn't do this right here because that would only give us 6 carbons. So we're going to go this way, all the way down to the very end to where we have 9. Now, so we have our base name, our non-ane. What we're going to do is give these guys a place in the name. So right here on this 7th carbon, we have a methyl coming out of it. So I'm just going to make note that we have 7-methyl. And again, referencing our carbon prefixes. 1 carbon is just a methyl. And on the same note, right here, we have 2 carbons. So that's going to be an ethyl, and that's attached to the 4th carbon. So 4-ethyl. And it's very important to put your dashes in between the number and then the name. And also on this 4th carbon, we have a chlorine. But whenever we write it out, we just say chloro. And to put this all together, we're going to have to put each of these separate entities in alphabetical order. So we don't pay attention to the number in this case. So we'll have 4-chloro, 4-ethyl, and notice how I'm using dashes, 7-methyl non-ane, because that's our parent chain. And that is it.
Sometimes you have a carbon compound with 2 rings, and they're put together with a bridgehead, like this. So in order to name these, you start by counting the carbons. You have 1, 2, 3, 4, 5, 6, 7. So that means it's going to be a heptane. And then, since it's 2 rings, you add the prefix bicyclo. And then you have to have numbers in there to help whoever's reading the compound figure out how it's drawn. So your numbers are the carbons in between the bridgehead. So first, we'll start here and count to this carbon. So you have 1, 2. So that is your first number, and your numbers go in brackets. So we have 2, dot, and then we'll do from here to here, which is 1, 2. There's another 2. And finally, we will do from here to here, and that's only 1. So the last number is a 1. And then to order those, you do bicyclo, open bracket, 2.2.1 heptane. And that is how you name a bridgehead carbon.
The first step in naming an enol is to locate and name the parent chain. In this case, we'll start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. since the alkene takes priority over the chloro group when you're numbering the chain, we'll start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. The second step is to name the substituent groups. So on number 6, we have a methyl, so we'll write 6-methyl. And on number 9, we have a chloro group. So we'll go 9-chloro. The next thing to do is determine the stereochemistry for our hydroxyl group. So the oxygen gets priority 1. This carbon here will get priority because of the methyl group, so that'll be number 2. And then this carbon will get 3rd priority, and the hydrogen will get 4th priority. So we follow it around, and it's going to the right. And since the H is in the back, we don't have to flip the stereochemistry. So it'll stay R. And then for the alkene, we cut the alkene in half and look at both sides. So here we have a group on top, that gets priority. The hydrogen that's coming off of here gets 2nd priority. And then on this side, the hydrogen up here gets 2nd priority, and the carbon down here gets 1st. So since the one groups are on opposite sides, we will call this one trans, and it's designated E. So the last step is to put it all together. So the first thing we'll do is put our stereochemistry in parentheses. So we'll have 2E for the alkene, and then we'll have 5R for the hydroxyl group. And then we'll put our substituent groups in alphabetical order. So we'll have 9-chloro, 6-methyl, and I'm running out of room. So then we'll name the parent chain here, non, and then account for the alkene, 2-ene, and then account for the alcohol, 5-all. So our name is 9-chloro, 6-methyl, non-2-ene, 5-all.
You guys made it so easy. Even a comm major can do it.